the introduction. Hi, everyone. I welcome you all to this webinar. And without further ado, let's get started and jump straight to the agenda for today's topic. So we'll be discussing multi-agent frameworks, a comprehensive crash course. So let's get straight to the agenda. We'll be discussing what is an agentic behavior, why do we need multiple agents, and use cases of multiple agent workflows. And then we're going to discuss how to build multi-agent workflows. And at the end of this theory session, we're going to do the hands-on exercise where we'll create a supervisor of multiple agent, and then it's going to route it to the relevant agent and then get the response from it. So I remember from the last year on the same month, I was teaching how to build chatbots like ChatGPT that can generate responses based on the text or based on the question you are giving. But now, as this LLM ecosystem has been developed and it has widened its use cases, now we are at this platform where we have to create an agentic behavior. So a food for thought for you is consider you're planning your travel or you're planning a travel to another country. So consider an agent that can actually book your hotels, book your calendar meetings, send out the invites, and then also set up your restaurants meetup as well. So an agent that can have multiple scenarios catered out for you, just like you have your personal assistant or you have a legal assistant or you have an advisor that can actually work your way through legal issues. So that's how an agentic behavior looks like in a concept of LLM based applications. It actually has this idea of acting autonomously and making decisions on their own and performing tasks with minimal human intervention. So, as I mentioned before, you can think of hundreds of such tasks that you can automate with an agentic behavior. And that's the beauty of AI, that you can actually avail all of these with just one click and one fire of the supervisor, and it's gonna do the reasoning for you, and it's gonna do the decision making for you all at once. So in this theoretical part, we'll be discussing what are some of the use cases of multi-agent workflows, how we can have a router agent, how we can have a supervisor agent that can have multiple hands of different agents and then iterate it as the need occurs. So let's move forward over why do we need multiple agents? So consider you are leading a team of 12 different people. One is from the marketing team, one is from the sales team, one person is from the uh, HR or legal team. So these different domains can only be work efficiently when you have different owners of this domain. So in order to understand a multi-agent scenario, you must think of it like you are working with an organization that have all of these different domains, and then you will be picking one point of contact from all of this domain, and that point of contact will do all of the chores related to that domain. So if I draw something really quick on this slide deck, so it would look like something this, like you have an organization, a CEO over here, and it has all of these different domains. You have a sales team, you have an HR team, you have a marketing team, and then you have a legal team. So a multi-agent workflow can actually help the CEO as a personal assistant, whether he wants to ask what was the sales revenue. So if the question was what was the sales revenue, this personal assistant agent would actually route this query towards the sales agent. And if this CEO asks if they are going through a set of HR policies, or if the CEO wants to ask about some HR policies, he can just this personal assistant can just route the query towards the HR agent. So consider all of these different agents as separate logical units. And then this personal assistant would actually route your specific query towards the domain you're asking the question from. And that's how just one supervisor can actually skyrocket your efficiency and productivity, and each agents get to focus on their area, their expertise, which actually helps in minimizing the bottlenecks and maximizing the output. So this is the new era of AI and LLMs that people are moving forward towards, and this is how this superficial intelligence and the AI would actually rule the world with multi-agent scenarios. And then they will have multiple skill sets that they can actually acquire as they are learning their way forward towards that. So here is an example of what I have previously discussed. Let's take an example if you just have a single agent system where it is just used for writing the content for you. So now most of the people critique about how do we know that the responses AI is generating is good enough, or maybe they are not hallucinating. So then we can also have an agent that actually judges the responses output. So I have been in a conversation with a number of people. Uh, as I meet them, they always ask, how do I rely on the responses from AI? How can I be assured that this response is 100% true? So in order to answer to those questions, let's say we have a critic agent as well. We can have an LLM. There's a concept of having LLM as a judge. So whatever the response we will get from this agent, let's say I have this agent one. So I ask him to write the content for me. And on the other hand, I can also, once I get the response from this agent, I can still pass this response to a critic agent or the judge or the panelist that is going to actually rate my response, whether it is 4 out of 5, whether it is 3 out of 5. And based on that rating, I'm going to pass this to another agent to to incorporate the feedback. So I'm going to collect the feedback from this judge or critic agent. So I'm going to, so it will look like a closed loop where you are iterating over the feedback. And once you have the accuracy of 95% or 98%, then you would call it that this response has been iterated over and over again. We have incorporated the feedback from the judge or the critic agent. And that's how you actually progress in this era, where you actually try to reduce the hallucination of these agents. So that's why we really need a multi-agent scenarios where we set up those agents so that it can put our evaluation, it can put our guardrails to a certain extent where we don't have to be on the back foot that whether this agent would be a good fit for the response or would be a good fit in healthcare or not. So there are multiple scenarios that we can think of while we are ensuring the compounding effect in multi-agent scenarios. So as we move forward, there are multiple use cases that we can utilize while we are working with multi-agent scenarios. As I mentioned earlier, let's take this as an example of CEO of the company, and this router is the personal assistant to that CEO. And then we can check this agent as, I'm gonna call it as legal agent. I'm gonna call it as marketing agent. I'm gonna call it as sales agent. And then this is the final response that I'm going to get it. So if the CEO asks a question that is, what's the revenue of from the last year, or what's the revenue from last month revenue? So to my intuition, I would know that this question should be asked from a personal from the sales team. So a personal assistant of this CEO would actually route this query towards the sales agent. And if I ask what was our spending limit of on Facebook ad, how much amount of dollars we have invested, what was our investment, uh, what is our investment on Facebook ads, investment on Facebook ad last month. So this query would be routed towards the marketing agent. And these agents would have a set of their own prompts, would have a set of their own knowledge base, and then they are connected to their own ecosystem. So consider them as a different logical unit that have their domain expertise. They are trained on the data that we have given to the salesperson or given to the marketing person or given to the legal person. And then we can ask a similar question that this personal assistant, or you can call it as a router, that is going to route the towards the agent given the set of given the set of questions that have been asked by the CEO. So this was one set of example. Why do we really need multi-agent scenarios and how we can actually incorporate it in our in our daily lives and how we can actually productionize this for the use of our customers. So as we move forward, we also have an example of a consolidator workflow. Consider consolidator as somewhat, let's take another example. Let's say you have 3 different agents, and let's take the similar example. You have an agent from your HR domain, you have an agent from your sales domain, you have an agent from legal domain. And what if the CEO asked, what was the cumulative investment we did in our sales team, with our legal team, with our HR team? So this consolidator would actually get the response from agent 1, get the response from agent 2, get the response from agent 3, and then it is going to consolidate all three of these responses, and then consolidate all of them, and then you get the final answer. So this is how a consolidator workflow also works in the setting of production environment and how you're moving forward with that. Now take another example of a sequential workflow. So in this sequential workflow, you actually want your agent to perform certain tasks after they have completed the first task. Let's say I'm going to ask it, let's say my question is, this agent is for web search. It is going to do the web search for you, and it is going to write a code for you, write code, and also execute it. And this is for writing a detailed report. And then all three of them would be consolidated. After that, you will get the final response. All right. So for me, if I read a couple of questions, so let's think about a scenario, how this consolidator workflow would work in sequence. So let's say if I am working in a medical institution, let's say I'm a radiologist. So for me, I want to search something over the internet. What was the, what are the basic principles of of writing an MRI report, or what are the basic principles of going through a CT scan, you can ask such similar questions that you can get the information from doing a web search. So considering that I am from a medical domain, I'm going to ask this tool to actually search the best practices, the best practices, the best practices for for writing for writing a detailed MRI report. So this would be the task one of this agent. So this would be executed by this agent one. Then I'm going to ask this agent to calculate or generate some bar charts or plots for this given the data I have searched over the internet. So I'm going to ask it uh, calculate the calculate the increase in salary over the past few years for radiologists, for a radiologist over the past 5 years, 5 years, and draw a bar chart for it. And this is what we are going to do in the hands-on exercise as well. And then this would be the task 2 of this agent. And then the task 3 would be considering the plot and the graphs and all of these examples, generate a detailed report for my assignment. And this would be done in a form of chain. You can also call it a chain of thought. So these agents are called React agents, which actually works their way in such a way that it first reason it and then act according to it. So they are called React agents. They reason it given the set of tasks, and then they act accordingly. So this was one of an example of how these consolidator workflows works. Now you must have been arguing it. What if I want to skip some of these agents? What if I don't really utilize all of them? So then you can also have some conditional edges where you don't want to actually incorporate all of them in your working environment. Let's say you want to skip the legal agent for quite some time. Let's say you want to skip the sales agent. So this back and forth of agent conversation is what we call multi-agent workflows. And please feel free to drop the questions in the chat. I'm reading it one by one, and at the end of this session, I'm going to respond to all of your questions. Just have some patience. All right. So let's move forward towards how we are going to build an agent workflow, how we are going to build a multi-agent scenario, and what are some components of building such agents. So in order to build a multi-agent workflow, we just need to remember 3 things. First is the nodes. Nodes are basically your legal agent, your sales agent. So nodes are just the Python logic that actually drives your agent. So this is just the logic unit that actually drives your way towards it. Then you have edges. Edges are there just to connect the nodes together. Let's say you let's say you have these edges where you actually connect all of these nodes together. And then sometimes you can also have conditional edges, which are your decision makers, that you have to actually enable the decision making within the graph. And then these 3 principles are more than enough for actually building and hands-on building a multi-agent workflow. So in today's session, we are going to build a similar supervisor agent, and I'm going to share the notebook with you guys after this entire webinar as well, so you guys can go ahead and try it and then tweak it as per your requirement, and then you can move forward with how you actually want it to be. So this would be a user. You can call it as any customer. If you're trying to fulfill any request, you can call it. So there was one scenario we have been working on for quite some time. Let's say this supervisor agent is built up for an healthcare industry. So think of some agents that a person who has been diagnosed with some issues. Let's say a person is a cancer patient. So think of some agents that this cancer patient actually need. Uh, think of some doctors, think of some consulting appointments that this cancer patient really want, so that he can actually move forward in his life with certainty. So the agent one would be a doctor that knows all of his history, a doctor that has all of his medical records. And then the second doctor would be his nutritionist, or anyone who has all the knowledge of his past history, of his past medical records. So this could be his personal nutritionist. And the third agent would be anyone who would be there for his palliative care. So now, as a cancer patient, if I ask about some questions uh, uh, related to what was the summary of my last CT scan. So this supervisor last CT scan summary. So this supervisor going to route this question towards this agent one. What if I ask, uh, what vitamins should I consider while I'm taking this tablet? What vitamins should I take when I'm on these tablets? When I am taking XYZ tablets. So this question would be routed towards the second agent, towards the nutritionist, who have the complete understanding of what are the tablets this person is taking and how he can perfectly align it towards the nutritionist. And then the third question would be, if your cancer patient is having some issues with his health, if he's having any health issues, it is going to direct it towards the palliative care person. So consider all of these agents, they have their own personalities, they have their own skills, they have their own personas. They have been built meticulously based on the agentic information we have built on it. And having said that, then you build a supervisor or a router agent that is actually going to route these queries towards a certain ideas. Or think of an idea that it needs a consolidator sometimes, and the consolidator would look like something that this agent would be directed towards from this. After getting this medical records, it is going to send all of this information to the nutritionist, send information, and based on this information, I'm going to get the final answer. So this is the context I'm sending it towards the nutritionist. And having said that, this would be a consolidator workflow. It would look something similar to what we have learned here, that this is your nutritionist agent, or you have your medical records over here. and then you pass those medical records to the third agent to actually give you some ideas about what is your medical history. And then once you have your medical history records, and then you can pass it towards the third agent, which will be your nutritionist, and it is going to advise you based on that. So it is going to give you advice uh, on what vitamins you should take. So that's the overall uh, theoretical part of it. Why do we really need workflows? What are router workflows? And now we're going to move towards the hands-on exercise. And as I've said before, I'm going to give you guys the access to the slide decks and give you guys the access to the notebooks so that you guys can try it on your own. So without further ado, I'm gonna take you guys towards the multi-agent supervisor I have created. And in this agent scenario, first and foremost, we'll be going through it line by line, but you don't have to get overwhelmed with of, with the number of technical jargons I'm going to use. You don't have to get overwhelmed. You will have the notebook. You can just install the dependencies and then try it on your own. So let's get started with our hands-on exercise. So in the first cell in this code cell, we are installing all the required packages. So it requires LangGraph, LangChain, and LangSmith and Pandas libraries so that they can smoothly run towards it. So in this working session, we'll be creating a supervisor agent which will have access to two different agents. And based on our quotient, it is going to route to a specific agent. All right. So as you mentioned, we have installed our library. So the warnings, you can neglect them. You don't have to worry about it. Just the version of pip that actually gets updated again and again. So you don't have to worry about it. And then you set the environment variables. So we'll be using Tavily search. For our web search tool, and we'll be using OpenAI API key for getting the responses and using GPT-4o. So moving forward, we'll see how we're going to create tools for this agent, how we are going to set up the nodes, how we are going to set up the state for this agent, and then we're going to move forward to this. All right. So before I go into the intricate details of this tool, let me actually have a slide deck, a plain slide deck, so that I can explain each block cell again and again. Let me copy and paste all of them here, and then we can have a discussion on it. Okay, just give me a minute. I'm gonna create a new slide. Take the screenshot of this because this is the way of I like to teach. Instead of running over the code, I would love to explain it using the screenshots so that it is easier for you guys to actually absorb all of this. Okay. All right. So I'm going to go back to sharing the screen. All right. So as I mentioned earlier, that this supervisor, you can call them as agent or you can call them as tools. So let me actually draw the graph again. So we will have a supervisor agent, and this supervisor agent will have access to tools. This would be a web search tool, and this would be a tool called Python REPL, which helps you in writing the code and then executing it. And based on the quotient that has been given to this tool, it is actually going to route to a specific agent. So if I have to draw it again, so based on the question I'm going to give it, this supervisor would actually detect the intent of that question. It detects the intent of this question and then route it either to the web search tool or the Python REPL tool. So first and foremost is we are creating the tools, the Tavily search tool and the Python REPL tool. It just we import it from the library, these functions, and then we just initiate these functions so that they can actually work their way towards it. So this is one set of thing that we have initiated the tools. So this is the code cell that actually helps you in initiating the tool. And as we move forward, now you see we are creating a supervisor and we are passing a prompt to this. This is the prompt for this supervisor, that you are a supervisor that actually manage the conversation between the following workers, and it actually respond and take the task based with their results and status, and then it actually perform those things in a sequential order. So these are the prompt that we have already written to our supervisor, and it is going to adhere to these things, and then they are going to move forward from there. So this is just the gist of it, and we're gonna see this. We're gonna run this self block and see how we are moving forward with it. All right. So up till now we have discussed how do we create tools. So I'm gonna run this. And then we have helper utilities. It is just the message block that we actually set it for our agent node. That is one set of thing for us. And then we have agent supervisor. And this agent supervisor has this system prompt. And based on that, it also comes with a number of it also comes with a prompt template where you actually give this prompt to your specific tool that given the conversation about who should act next, and then you give the options for this tool, whether you want to have the option for a researcher, whether you want the option for the coder. So these are the names we have named it. We have named it as researcher, and this is as coder. So let's move forward towards the next block of cell. And please feel free to drop questions if you are facing any difficulty, and if you didn't understand any of this line of code, we would be happy to help. Just drop the questions and then we're going to respond to it in next 5 to 10 minutes. So once we run this cell, we have initialized a supervisor agent. Now we'll create a graph of this agent. As I mentioned earlier, we have these specific elements separately constitute. We have the tools, we have the supervisor. Now we'll create a graph of it. And as I mentioned earlier, to create a graph, you have to mention the nodes and the conditional edges, as we mentioned earlier. So this would be our node 1. This would be our node 1. This would be another node. And then we will have the conditional edges. And so consider you have these logical units created. Now you are spacing them or mapping them out in a form of graph representation. So this is what we are going to do in this block of code. We are importing all of the required libraries. We are initiating a class, and based on this class, we are going to set up the nodes of this workflow. So we have a researcher node, we have a coder node, we have a supervisor node, and based on this node, we are setting it up our mapping out our graph on this. And once we have all of those nodes ready, if I go back, so this would be another node of supervisor. So now, as I mentioned earlier, in order to make a graph, what do we want? We want a node, conditional edges, or just, you can call them just edges. All right. So if I go back to the code, I would see that after we have set up the nodes, we will create edges in the graph. And these edges would be the decision makers. Whether should I go towards the coder, whether should I go towards the researcher, etc., etc. So now we will initiate and compile this graph. And based on that, uh, all right, so it says that the supervisor already exists. So you don't have to actually rerun it again. And feel free to drop the questions in the chat. I'm reading out the questions from, we have a question from Mike, we have a question from Robert. So the notebook link would be provided to you, George. Don't worry about it. We'll share it at the end of the session. And we can take the questions as of now once we have constructed this graph. So if I go back to the slide, you can see that once we have these nodes ready, all we need to do is set up the conditional edges. And these edges would be what you actually want from this tool to actually work. All right, so we have a question from George, and I really want to answer it as a right away. How deep should the context and information that is given to a specialized agent so that he can reliably carry out his task in that domain? George, the context to this agent, you should actually pass it 100 lines of prompt or 200 lines of prompt, but the gist of it, or the recipe of a good working agent, is the LLM you are using behind it. So if you are using GPT 3.5 versus a GPT 4, it's gonna make a huge difference behind it. So yes, I agree with you. The domain knowledge is really important, but it also important what is the LLM you are using behind this agent. I hope that answers your question. All right, so Mila has asked, is there an easy way to generate a UML diagram from the LangGraph code? Yes, there are a number of startups that have just solely focusing on creating multi-agent scenarios. There are some applications that don't really rely coding. So there are some applications that are no code multiple agents. So if you go to the internet and ask how you create an agent without code, you will find all of the names to that. And the question from George again, that whether it's not the case to have a better understanding to have a RAG agent. Yes, absolutely. In the third case, you can have a RAG agent, RAG, which is also called retrieval augmented generation, is also something you can have in as a third agent, which actually gets the data from your knowledge base. And based on that knowledge base, you actually generate the responses. So it is something that we also are working on. We have a multiple agent scenario where we actually set up the web search agent, the Python REPL agent, the RAG agent, all of them together. So now as we move forward towards this in how we invoke this. So see this question I have asked from this agent, write the detailed complete code for HTML, CSS, JavaScript for a simple portfolio for James. The website should have sections for about me, project skills, etc., etc. So right now I'm asking this question for this agent to generate a response, to generate a detailed complete code for HTML, CSS. And once we run this cell, this code cell, it is going to give us the response that the supervisor has started the coder, which is exactly correct. And then it has also given us the response of this, that the code to this portfolio website is here. And you can just copy and paste this portfolio website code in index.html and you will have your portfolio ready. So there is a coder agent which actually writes the code for you. And then you also have a researcher agent. So I have asked this researcher agent to write a detailed research report on radiology. And it has a recursion limit of 100. So it's gonna iterate it over and over again. And you can see that this supervisor has routed this query towards the researcher agent, and you get the report in a structured format. This is the introduction to radiology. This is the history of radiology, types of imaging techniques. You have X-rays, you have ultrasounds, etc., etc. So there is a wide variety of use cases that you can utilize if you are working in a healthcare domain, if you're working in a sales domain, you name it, and you can build a multi-agent scenario for that. So that's the entire walkthrough of the theory and practical part of it. But we still have some time left and we'll be answering all of your questions directly. So please feel free to ask questions if you have any. All right, so I'm going to scroll up the chat and going to take the questions from the start. All right. Okay. All right. So here's this question of how would this multi-agent works in a healthcare environment? So I'm gonna address that. I have already addressed this before. That consider you have a patient that has been diagnosed with cancer. So having said that, this cancer patient would require consultation from the doctor that already knows all of his medical records, the nutritionist, and the palliative care. So having said that, any question that occurs on the fly towards the supervisor, it's going to route it towards the specific agent, whether it's about his medical records, whether it's about the nutritionist, whether it's about the palliative care. All right. So are there any other questions so far? George is saying you can also have an oncologist. Yes. And you can also have another agent that would be the legal advisor for your cancer patient so that they can get the insurance benefit for them. This would be a legal advisor. All right. Can I use OS LLMs like Llama outside of LangChain to build this type of agentic framework? Sampreet, absolutely, you can use LLMs that are deployed on your own that are deployed on your own cloud platforms or on premise. You can absolutely use all of them. It's just the point of calling an LLM and then just passing it the right instructions. It is going to work as per your requirement. Same. All right. So there is this question from David Tarrant. Uh, and then there is this question from George again. Can you please talk about optimizing cost and token consumption when it comes to multi-agent system? So I'm going to address both of them together. Let me actually have another white screen. So let's take this question first from David. David is asking whether the chaining creates separate round trips to an LLM. So David is asking how the chaining works and how does it work in an LLM setting if we have agentic behavior. So David, if I remove all of this again and I come to this example again, let me remove it, have my eraser. Okay. All right. So chaining with multiple agents somewhat look like this. It's a sequential chain that have all of these agents set up. So for chaining, we really need to have a basic principle of the chain of thoughts. So chain of thought is something we have to actually understand before we move forward from here. So consider chaining and multiple round trips of coming to the same agent, which means you can have a web search tool over here that is going to crawl the internet and going to get the responses from Google or Bing or DuckDuckGo or Tably search. And having said that, this web search agent is one of a kind of chain that you are going to utilize. And then this web search, let's say if I want to ask about the stock market, that about the XYZ stocks rate from the past rates from the past 5 years. And getting this response from this, I'm going to ask this agent to generate plots for me. So it is going to write the code and generate the plots for me. And once you have this chain executed, now you will ask it to write a detailed report based on the plots plus the data we got from the internet. And once you have the detailed report, you're going to ask the consolidator to generate a final response for it. So that's how chaining works and they are also called React agents, which means they reason on a certain idea and then act according to it. All right, so we have two more questions. Can these agents use different models for their processing? Absolutely. So if I really believe GPT-4o or any other model is good in certain ideas, I'm gonna pick that up and I'm gonna let me actually draw it again. So I can call it as this agent can use Llama 2 or Llama 3. This plots, I always admire agents from Claude. You can use any agent for generating plots. And I'm gonna say that the detailed report writer would be my GPT-4o, and this could be any agent from Claude. So yes, all of these agents can use different models for processing. Are we going to have a similar session on multi-model as well? So for multi-model scenarios, you will have multiple models that can generate images, that can generate videos, that can generate text, and then setting up all of them together, we have a certain thing in one of our project. We have been building that. So it actually looks like something similar if I have the pen ready. So a multi-model scenario is when you have access to both configurations, whether it is generating a voice, or generating images or generating videos. So these are some capabilities that you can avail using multi-model workflows. So there is this question from John. Do you recommend that we create a system where an agent can actually create other agents as needed, or should the agent should be established and consistent? That's a really interesting question. So, John, you're saying that we just create a supervisor and it is going to work its way on its own, whether it wants to use a certain agent or not. So, instead of that, think of developing 100 skills for your agent. And then on the fly, that supervisor would actually detect the intent of the query, and out of from that 100 skills, they picked one skill and then do the iteration on it, and then do the end-to-end work on it. So I would rather recommend having 100 skills and then letting the supervisor pick one from it, or just building a supervisor that can create agents of its own. It would be somewhat dark, because what if it creates an agent that is going to hack a few websites over the internet? Because that would be something out of control. So that is what a big organizations and companies are targeting over that super intelligence in AI, that the agent would actually create minor agents on their own, and then they are going to do their task. And once the task is accomplished, they're going to destroy those agents. But what if they never destroyed them? So that is a food for thought for you, John. So Sean is saying, why not have the 100+ agent debate and decide who is the best to take the task, or even collaborate between each other for different functional roles? So, uh, so it looks like we are going towards more or like bureaucracy, where we are thinking about what to do and what not to do. But I would rather recommend you guys to actually start with the basic principles. Start with creating 2 to 5 or 10 agents, then discuss how do you really want to move forward with it. Okay, so there is another question. Do you have examples of real companies that have productionized a multi-agent platform? What are some of the state-of-the-art software out there in the world? All right. So so there are a number of companies who are, you must have heard about Creo AI. They have their AutoGen, which actually do all of the work for you. And then there are a multiple such companies that are building on top of it. So you can go over the internet and search about them. We are also working on multiple agent scenarios for some of our clients. And then in our bootcamp, we do teach a lot about how to create such workflows and how to create such softwares from the scratch to build multi-agent workflows using open source libraries and repositories. All right. So any other questions so far? Anyone?
I think, okay, you have one more question.
Okay, let's take the last question. How are you evaluating the quality and correctness of individual components, router correctness, agent task, final response accuracy, human feedback? That's a really good question. And it is from Rich Young. So, Rich, there are a number of companies that are built on just evaluating these LLMs and multi-agent scenarios. So, what we can do so far is on every LLM call, on every wherever you're using an LLM call, you can just directly, once you get the response, you can just directly pass it to your evaluator, And based on the evaluation, you get it whether it is 90 or 95% accurate. Based on that value, you are going to give the feedback to the agent and pass it towards the pipeline. If the accuracy was 70% or 60%, it is going to withhold the task there and not allow you to move forward from there. So there are some other examples you can take of how whether wherever you just call an OpenAI LLM or just uh, call it to actually execute a task, you can always have an evaluator node there. All right, guys. It looks like we have our time, and then I see there are no other questions left. I would